spell work problem that up until today would probably be the hardest part about this homework because it does have a slant asymptote. Today we get a little more difficult because we're going to add inequalities into the mix. But this is probably the hardest graph because it does have a slant asymptote. Bobo is pretty easy because it's just y equals 0. And the other hard part is two verticals because then you have to plot a couple extra points. Ugh. But it's not hard. You're just plotting extra points. It shouldn't be a deal breaker on whether you're going to do the problem or not. All right, so the first thing I'm going to look at is my powers. So I have a 2 and I have a 1 here. 2 and 1, so I'm looking for my horizontal asymptote, so I'm using Bobo-Botten eats DC. Well, it's bigger on top, so that's Botten. So I'm not even going to write horizontal asymptote because Botten always means we don't have a vertical or a horizontal asymptote. And in this case, we have a slant asymptote because 2 is 1 bigger than 1. Slant tells me I need to divide. I need to actually do the division. Either I have to use long division or I can use synthetic in this one. I can use synthetic because it is x minus 2. If it was x squared minus 2, I'd have to use long division. But because it's x minus 2, I can use synthetic. And in fact, I am going to use synthetic. Just remember with synthetic, I'm basically using that number that would make it 0. So I'm synthetically dividing with 2. I'm dividing x minus 2. I'm seeing 2x squared minus 5x. So I have 2x squared minus 5x. But I do have to account for the fact that we have 0 constants. All right, carry down that 2. 2 times 2 is 4. Negative 5 plus 4 is negative 1. Negative 2. Negative 2. We look at this nice remainder and you say, hey, you're a remainder. I don't care. I don't care about you. You have nothing to do with my slant. The only thing that has to do with my slant asymptote is this 2 and this negative 1 is actually my slant asymptote. So my slant asymptote is going to be y equals 2x minus 1. That is my slant asymptote. Let's go ahead and just graph that. Let's start off graphing that. I'm going to skip every other line because it will fit and it'll be fine. I'll make it a little bit better of a graph. So I'm going to count each of those tick marks as a 1. That way I'm not trying to write really, really tiny. So that's 1. That's 1. Let's look real quick. Okay, that's 2x minus 1. That is in slope-intercept form. So we cross the y-intercept at negative 1. Cool. And then we are going to have a slope of 2. So that's up 2 over 1. Up 2 over 1. Up 2 over 1, so something like that. So we have a slant asymptote that looks something like that. All right, then let's get our vertical asymptote. Let's get that out of the way. Vertical asymptote. This is the really tough one because it changes every single time, or in fact, it doesn't. Just set your denominator equal to 0. Denominator equal to 0, x minus 2 equals 0. We have x equals 2. Boom, boom, boom. We draw a vertical line at x equals 2. Now we just have to decide, is our graph up here or is it in this little space here? Is it in this little space up here or is it down here? Just plot points, guys. Just plot points. So we need to pick at minimum 2 points. I need one left of my vertical asymptote and one to the right. Well, I always look to see if I can use 0 on either one of them. And I can use that point 0 on the left-hand side. 0 is left of my vertical asymptote. So let's use that. When I plug 0 into my original equation, I'd have 0 on top, negative 2 on bottom. So that's 0, 0. So plotting the point 0, 0 is right there. It looks like we're going to be something like that. We're just going to hug these asymptotes like that. All right, more than likely, my other graph is right here. All right, looks something like that. And if I'm on a test and I'm completely out of time, I'm just going to quickly draw that down and go, here's my test, Mr. Pavian. I'm pretty sure that's right. But since we have time, let's go ahead and plot the point. It looks like to the right of my vertical asymptote is going to be 3. So let's plug 3 in. 3 is going to come out. Ooh, I don't even have mine anywhere. Did anyone plug 3 in? Yeah, what did you come up with? 1?
I got 3.
I got 3, I think, now that I'm remembering it. I think it's 3 and 3. I think so. Yeah, so 3, 3 sounds like my memory of what that should be.
Oh, because it would be 3 over 1.
Yep, it would be 3 over 1. Yep. Which gives you 3, usually. So we'll plot the point 3, 3.
Unless you're me.
Unless you... So we'll have something that comes up like that, comes down. Doot, doot. Oh, we got that graph. All right, questions on that? All right, questions on the homework. Oh, sorry, I missed. Oh, sorry.
Not specifically this one, but
Okay.
one in general. Are you able to use synthetic division with any odd powered x?
Not technically. Don't use synthetic unless it's x minus 1.
Okay.
That's when it's assured to work. There are cases where it does work, but I don't want to go through all the ones where it does, because then you go into the I before E except after C except for all of these other cases. You know what I mean? So I would just say if it's x minus 2 or something, use synthetic. Anything else, just use long division just to save yourself from, because you don't want to have one of those 15 possible, Great question, though. Other questions on just this or in general? Okay, then questions from the homework. Yeah, Fatima. 43. Oh, this is not it. I don't even know if I have that homework up here. Which one was 43?
It's the special case one.
Oh, the special case one. So the whole thing is your denominator in 43 could be rewritten as x minus 1 times x minus 1. So my whole point of doing that problem is to look at this. We basically have two vertical asymptotes, but they're in the exact same place, which means this could be a special case like that one was. So it won't fall into our, I can't remember, was this a Bobo one where it was, so it was y equals 0.
Yep.
Is that right? Okay, and then y equals 1 was another one. Now normally we would know that, hey, if I have a point up here, it's going to look like that. If I have a point below, it's going to look like that. Well, the problem is we have two vertical asymptotes in the exact same place. So that can create a problem with our graph. What that tells you is you need to plot additional points. You need to plot one close to your vertical asymptote, and you need to plot a couple away from it. So I'd probably plot 3 points. I'd plot a point over here. So if I plotted a point over here, I'd have something here. I'd plot one a little closer, which would be maybe about here. And then I'd plot one close, which would actually be here. Which would tell you this is a very weird case where it tries to pull away and it's just like, psych, and it goes back up. All right? So you just have to recognize if you have two vertical asymptotes in the same place, something weird can happen. So check some additional points. Okay? Do you think that's enough? It's hard to say exactly.
That's what I had a problem with.
Yeah, it's hard to know exactly what it's going to look like because sometimes it will behave normally. You just have to plot points to figure out what it looks like. Just know something weird happens here. So if you're on the test and I put this on there, just put something weird happens here. I didn't have time to plot enough points, but I know something might have happened because then I know you're at least looking for it. Okay, let's get into today's lesson. Today's lesson is half stuff we've already covered, just because it comes up. It is holes. It is holes in the graph, which we've already done. A hole in the graph occurs when you have something like x minus a in the numerator and in the denominator, like we did yesterday, where we could cancel it out. So my example here is x squared plus x minus 2 over x squared minus x minus 6. We can factor both of these guys into xx. I need something that multiplies together to give me 2, so I know it has to be 2 and 1. That has to be it. It is negative 2, so one of them needs to be negative, one of them needs to be positive. Let's make the 2 positive, the 1 negative. That seems to work. All right, in our denominator, I did say it will also factor, so that should work too. We either have 6 and 1 or 2 and 3. Well, I look at the number in front of x, which is a 1. So the difference between what I'm multiplying has to have a difference of 1. So that is 2 and 3. One of them needs to be negative, and it turns out it's the 3 because we end up with a negative 1 when we add them together. So this was the case where I am allowed to rewrite this as x minus 1 over x minus 3. However, I do have to note there's a hole at x equals negative 2. But this right here leads me to my vertical asymptote is x equals 3. So I can get two things out of there from that. Now, I want to point this out one last time for us to really focus on this. If you plug in x squared plus x minus 2 over x squared minus x minus 6 in your calculator, and then you plot x minus 1 over x minus 3 on another calculator and you compare them, they're going to be the exact same graph because your graphing calculator does not graph holes. The only difference from this big long equation and this one on your graph would just be a hole. This one has a hole at negative 2. This one does not have a hole at negative 2. So that's why we have to note I can rewrite this as long as I recognize there's a hole there. Okay? Otherwise, they're the exact same graph. And your calculator will not be able to find it on the graph because it does not show a big old hole. It would be. I think some of the newer ones do. Like you can. Sure. Our next problem is just we're supposed to graph it. We're supposed to graph it with a hole. We've already done this. This isn't anything new. We just did it. Now we're just putting in a section where I can go, these are where my holes are section. So we're supposed to identify points of discontinuity, holes, vertical asymptotes, horizontal asymptotes. All we're really looking for is vertical, horizontal, and holes. That's what we're really looking for. Okay. So anytime I have something squared on the bottom, I'm going to think that's a difference of squares. So let's go ahead and rewrite that. The top I can't really rewrite, so I have x minus 2 over difference of squares gives me x minus 2 times x plus 2. Once again, I can rewrite this. I can cross those out because that turns to 1. And we just have 1 over x plus 2. But in order to do that, make sure you write you have a hole at x equals 2. Bless you. Because these two things aren't exactly equal. They're only equal if I recognize that we have a hole here in this graph. All right, so always signify you have a hole before you rewrite it. All right, but now we can treat everything else the same. We can say, well, let's find our horizontal asymptote. Since both of these graphs are the exact same, except for the hole, I can use this one to find my vertical asymptote and my horizontal asymptote. So I can use the 1 divided by x plus 2 here on out, once I signify that I have a hole. So I'm going to use that 1 over x plus 2 to come up with my horizontal asymptote. That means I have x to the first and the bottom. I don't have a power on top, so that is bigger on bottom. That is Bobo. And Bobo says y equals 0. Vertical asymptote. Ooh, these are the tough ones. You have to set your denominator all the way to 0 and solve. So you have x equals a negative 2. Let's go ahead and plot these. I'm going to once again skip. I'll go 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I have a y equals 0. Bobos. I hate Bobo too, because I hate with a pencil writing that horizontal asymptote at 0 because it just disappears in that black line. But we do have a vertical asymptote at negative 2. That doesn't even reach it. I was on the wrong line. There we go. All right, now I have to plot 2 points. I need one to the left and one to the right. My advice to you, since you already have to plot that hole anyway, you have to know where that hole is to put it on there. use your whole to come up with one of your x values. So I'm going to check where x equals 2. Now remember, I need to plug that into my new equation, that 1 over x plus 2. If I plug 2 into the original, you come up with an error. So you plug it into your new one. So that is 1 over 2 plus 2, which is 4. So that's 1 over 4. Let's go ahead and plot that point. 2 and 1/4 is right here. But here's the problem. I don't want a closed dot because it actually is a hole. So we're going to put a big old open dot there. And that dot allows me to draw the rest of my graph. And it might be a good idea just to note you have a hole there. So that's why I do my hole first. Now I just need to plot something to the left. I don't need to plot additional points over here because I know what it looks like. So we're going to go to the left of it. So that's going to be, let's plug in -3. Let's see if that works. Or -4 or -5, -6, negative, doesn't matter which ones, as long as it's to the left. So I'm going to do -3. That'd be 1 over -3 plus 2 is a -1. -3, -1 would be here. We just go whoop. We got a graph with a hole in it. Nothing new. We've done these. The only thing new we're going to do today is inequalities, and we're going to do one problem with inequalities. ¿Qué pasa? Sure. About something you just want to see her? I think I have a picture in the yearbook. A yearbook picture with that? No, okay. All right, we are going to get into inequalities. Now, before I start inequalities, I do want to say, we already did 2 methods. We did graph it. Graph it, put your line at 0, and see where it's above and where it's below. We also did test point method, where we come up with where our zeros are, and we test the points in between and to the left and right of those zeros to see if it's positive or if it's negative. You can use all those methods on these. Minus this first step. We always have to do this first step first, and that is to set it equal to 0. So we're going to start with this step because it has to happen every single time. So that's going to be our first step, is setting it equal to 0, or the equation less than or equal to 0, or whatever you have. In other words, I want a 0 on one side. So we're going to do x plus 3 over x minus 2 minus 2 is less than or equal to 0. But in order for me to graph that or know what's really happening, I need one rational equation. So I need to push that 2 into that fraction, which means they need to have a common denominator. So what I'm going to do is I'm going to multiply 2 by x minus 2 over x minus 2, which will look like this. We have x plus 3 over x minus 2 minus, I'm going to throw that 2 on top, and let's pick a color that will show up. So I just did x minus 2 over x minus 2. I'm allowed to multiply by 1. I don't care what you say. I'm allowed to do it. And that is going to be less than or equal to 0. Now, just to save me from making a stupid mistake, I'm going to simplify this just a little bit. I'm going to distribute that -2. So I'm going to change this to a positive sign, and I'm going to take that negative and put it on top. So that's going to give me -2x. -2 times a -2 is a positive 4 all over x minus 2. It just saves us from making a silly mistake later on. Now we're going to simplify this into one fraction. Since they have a common denominator, we just got to add together our x's, add together our constants. So I have x minus 2x, which is going to be a -x. Now I have 3 plus 4, which is 7. And that's all over x minus 2 is less than or equal to 0. At this stage, we could graph this, right? We're not going to, but we could graph this. It is just same on top as bottom, so that's each DC. So our horizontal asymptote would be -1 over 1. Our vertical asymptote would be at 2. We just got to figure out where it's going to be, plot a couple points, and we could graph this. And we could get a general idea of what our answer is. That is not what we're going to do. Instead, we're going to come up with It's very similar to me just picking points and checking to see if it's positive or negative in those sections, except we're going to check a whole bunch of sections to see if they're positive or negative. So we can check the whole system for positives and negatives. And in order to do that, we don't really care about values. Like, I'm not going to plug 2 in here and see if it's positive or negative. Instead, I'm going to say to myself, if my numerator is positive and my denominator is positive, positive divided by positive is positive. Well, positive wouldn't work in this one, right? Because it needs to be less than 0. So positive wouldn't work. But if I had negative on top, positive on bottom, negative divided by a positive would be a negative. Negative would work. I want to know all those situations where I'd get a negative out, and all those situations I'd get a positive out, and all those situations I'd get a 0 out. All right? That is what we're going to do in a nutshell. So it says down here, that's going to be our next step. Find all the values that make the numerator and denominator positive, negative, and 0. Okay, so we're going to make kind of a table of sorts. So we're going to have a numerator column, or row, I should say. Then we're going to have a denominator. That should be an I. And we're going to have a column that where I'm going to find where it's positive. And we're just going to start with that. We're going to start with positive. Then we'll do negative. Then we'll do 0. All right, our numerator. I want to see if my numerator is positive, where it's going to be positive. So we're just going to look at our numerator. Our numerator is negative x plus 7. So we'll do negative x plus 7. In order for that to be positive, that would have to be bigger than 0, right? You all agree with that? If that's bigger than 0, it has to be positive. That's the definition of positive. All right, so I would subtract 7 from both sides, and then I would divide both sides by a negative 1, correct? Maybe I should do all those steps, as long as I have my room. So we have negative x is greater than negative 7. Divide by negative 1 means I flip the signs. It is positive wherever x is bigger than 7. I'm sorry, less than. I said to flip the sign, but I never flipped it. I said it, I just didn't do it. All right, so that's where my numerator is positive. My denominator is positive whenever x minus 2 is bigger than 0. So that is x minus 2 is bigger than 0, in which case x needs to be bigger than 0. So my numerator is always positive when my x value is less than 7. 2. Yeah, I said it. I said it once again. I just...
No, you said 0.
Did I say 0?
Yeah.
You know what? I'm calling it a day.
Okay, that's fine.
You guys are still in charge of learning this.
This is a video from the previous class online.
No.
Okay then.
All right, so we have to have x is greater than 2. So we have our numerator is positive whenever x is less than 7, and our denominator is positive whenever x is bigger than 2. The good thing is that is the hardest work you have to do, because negative is just going to be the opposite. If our numerator is positive when it's less than 7, it must be negative when it's bigger than 7. And so our denominator, if it's bigger than 2, it's positive. Then it must be when it's less than 2, it is negative. Finally, we'll look at where it's 0. That's going to be that changeover point, right? This is going to be where x equals 7. And this is going to be where x equals 2. So you really just have to find one of these columns, and everything else is the opposite or in between. All right, now we're going to make a chart of all these values, where it's positive and where it's negative. So once again, we are going to have a numerator. I'm just going to call it num column, and we'll have a den for our denominator column. And then we're going to fill out some values. Now, most of the time, I wouldn't fill out all these values, but just for the sake of notes, I would just put key ones down. But just for the sake of notes, I'm going to put down 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll kind of show you what I mean by I wouldn't fill all of those out in just a second. All right, let's do our numerator. In fact, I should have moved this over. We'll just say our numerator. Our numerator, so let's go back to our numerator, is positive whenever x is less than 7. So at 7, our numerator is 0. Anything less than 7 is positive, so I'm going to make a bunch of positives. It doesn't matter how well you line them up because they're all just positives. Anything else is negative. So bigger than 7 would be negative, so 8 would be negative, 9 would be negative if I plugged it in, 10 would be negative, so on and so forth. We're going to do the same thing for the denominator. Our denominator is 0 at 2, so we'll put a 0 at 2. Whenever x is bigger than 2, it's positive, so we'll put positives all the way across here. And it's negative everywhere else, so when it's less than 2. Let's put down what the question was. The question was, I want to know when negative x plus 7 over x minus 2 is less than or equal to 0. In other words, I'm looking for when is it negative. And the only way to get a negative number with a fraction is you need to have a negative divided by a positive or a positive divided by a negative. So let's go ahead and write those parts down. So if I look at this section here, that's a negative times a positive. So this part would be negative. Let's go to the other spectrum. That's also a negative and a positive. Would give me a negative. Everything in between would be positive or 0. Let's look at our zeros really quick. 0 divided by a number. That just equals 0, right? So this right here is a 0, and I'll tell you why we're doing this in a second. What's a number divided by 0? Undefined. This is an error.
So there's a hole.
There's a hole there or an asymptote or something. This is just does not exist. So I have a 0 and a place that does not exist. Everything else would be positive here. But I don't really care about the positives. I just cared about the negatives and the zeros. And why I cared about the zeros is, you see this equal sign? I have to account for the fact that it's okay to be equal to 0. So I'm going to use brackets anytime I actually have a 0. All right, let's go ahead and put our answer down, having this knowledge. So if we look at that negative starts all the way from negative infinity and ends at 2, actually, but not including 2. Not including 2 because 2 does not exist. So we're going to go from negative infinity all the way to the 2, but I have to use a parenthesis because 2 is not included. In fact, it can't be 2. Because if I plug 2 in here, we have 2 minus 2, which is 0. I put 0 in the denominator. That doesn't work. All right, we are going to union that with, well, we have to include our zeros. We have a 0 at 7, and then it becomes positive everywhere else. All right, that's a method for solving rational inequalities. It's just coming up with your numerator's positive and where your denominator's positive and negative as well. And then find your zeros. Let's just say you actually graphed it. That's what I have on the next page. If you actually graphed it and you did negative x plus 7 divided by x minus 2 and you came up with a really nice accurate graph, you would just have to put a line at y equals 0 and just ask yourself, where's that graph less than that line or lower than that line? That'd be all of this and all of this. Note that we do have a vertical asymptote at 2. So 2 can't be included in our solution set. So it's less than 0 from negative infinity all the way to 2, not including 2 because there is a vertical asymptote. And if you look where that red line crosses with our graph, that actually is 7 to infinity. And I do have to include 7 because there is an equal sign. So I do have to include any place there actually is a 0. If this would have been strictly less than, then we wouldn't have that bracket. But since it's less than or equal to, I do have to include that bracket. which is the exact same answer we came up with on our other example. All right, questions on that? Real quick, I forgot what order I put them in. I don't think I did Langston. The first two problems you do have to graph because it does say identify the points of discontinuity and holes, vertical asymptotes, such and such. So you do have to do two graphs. Everything else has a graph next to it. But if you look at my answer key, in fact, I'll take a picture of my first answer because you can look at it online anyway. It's not like I'm hiding anything. I did not use the graph. No, I want you to, if you use a graph, you have to graph it.
Yeah.
But I didn't use graphing method.
I mean, like,
You can use you can use it to check it. But look at how basic my number line is. I just put where my 2 zeros were, and I just asked myself if my numerator is less than 4, is it negative or positive? It would be negative. Because it'd be 3 minus 4, 2 minus 4, and everything else would be positive. So your number line can be just this quick. In fact, if you're good at these and you understand what's happening, this is all the work I need to see, and it does go that fast once you practice and you understand what's happening. All right, so even though it looked really complicated because it's the first time kind of seeing it, it can be this simple, where you just have to ask yourself, where are my zeros at? For my denominator, if I'm bigger than 0, so we're talking about -1, -2, -1, 0, 1, 2, 3, 4, those are all positive. So that's why I have all positives here. If I plug something in less than -2, so that's -3, that would make it negative. -4, -5, so that's why all of these are negatives. So a lot of it can just be done in your head. That's what's nice about this method, is a lot of it can just be done in your head. Is it positive here or is it negative here? I also want to talk about the homework that has the kind of problem in it with the blanks. I want to talk about how to do it really quick. So that I'm talking about the one that says, who said what happens to dream deferred? Jack ruined it. No, I'm just kidding. It's Langston Hughes. They just proved that to me. I just want to talk about how to do it because it's slightly confusing. So look at number 1. Number 1 says find all the holes. And it says the holes are at x equals, and you should put down 2 there because x minus 2 cancels out with x minus 2. So for the very first problem, you're going to write down 2. Then you're going to go to that bottom left-hand box, and you're going to find 2 in that box. That 2 matches up with u. So here's where it gets slightly complicated. You are now going to look at those blanks. You're going to put, so for number 1, you're going to put a u above it. You're going to put a u above that number 1. And then it follows like that. So whatever number you get, you find what letter it is. So for number 2, if you think it's H, you're going to put H above 2. It's not H. Don't put H there. Yes. So you could check your answer because it is Langston Hughes. I don't know how many people